Week 1, Unit 0 notes for Math 1340. The first thing we're going to discuss is the law of exponents. The below table summarizes the basic laws for exponents. Before we dive into that, a little reminder. If you have an exponential expression like a raised to the n power, then we are going to call the a the base and n is the exponent. Now let's go and cover the rules. The first rule is named the product rule. The product rule states that if you have two exponential expressions that they have the same base and you multiply them or find a product of those two, then the answer is going to be you keep the same base and then add the exponents together. What does that mean? It means that, for example, if you have 2 raised to the second power times 2 raised to the third power, you have 2 times 2, that is 2 to the second power. This is what it means, times 2 to the third power, which means you multiply 2 by itself 3 times, 1, 2, 3 times. Now, if you combine these two by multiplication, you will notice that you have 1, 2, 3, 4, 5 2's multiplied with each other, which will be written as 2 to the fifth power. And that is the same as 2 raised to the 2 plus 3, the original exponents. So that is what the product rule says. The second rule is the quotient rule. The quotient rule is basically similar to the product rule in some way. We will discover that as we go through these rules. And it says if you have exponential expressions with the same base, remember, same base, then the answer would be the same base is kept, and then you're going to take the exponent of the numerator minus the exponent of the denominator. So exponent of the numerator minus the exponent of the denominator. For example, if you have 6 to the fifth power divided by 6 to the second power, then this means the numerator is 6 to the fifth power. That is 6 multiplied by itself 5 times. 6 to the second power in the denominator means 6 multiplied by itself 2 times. Now, we know that we can cancel. In division, we can divide 6 by 6, 6 by 6. The denominator is going to become 1, and the numerator will be 6 times 6 times 6, which can be written as 6 to the third power because I have 3 of them left. Using the quotient rule immediately, we can say this is 6 to the 5 minus 2. That is the power of the numerator, or the exponent of the numerator, minus the exponent of the denominator, which will give me 6 to the third power. The next rule is the power rule. The power rule says if you have an exponent expression and you raise that to a power, then the answer is going to be the base raised to the power of that expression times the power that is raised to it. Or the power of the power multiplies. The power of the power multiplies. The exponent of the exponent multiplies. Here is an example. If you have 3 to the second power raised to the fourth power, this basically means 3 to the second power is 3 times 3. And then if we repeat that 4 times, that means we have 1, 2, 3, 4 of that expression. Now, in general, if you count if you do the multiplication, because those are all multiplied here, basically if you drop the parentheses, you will end up with 3 times 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 3, 8 times, which will be 3 to the 8th power. If we apply the power rule immediately, this is going to become 3 to the 2 times 4, because the power of the exponent multiplies, which is going to give me 3 to the 8 power anyways. The next rule here is the zero exponent rule. The zero exponent rule states that if you have an expression and you raise that expression to the 0 power, the answer is going to be 1. It does not matter what that expression is. It's always the case. If you raise any expression to the 0 power, the answer will be 1. For example, 25xyz raised to the 0 power is equal to 1. The next rule is negative exponent rule. So this rule goes both ways. If you have a negative exponent, it is the same as saying if we need to turn it into a positive 1, then the denominator here is 1. We're going to push that into the denominator and change the power to a positive. And it goes backwards as well. So for example, if we have 1 over a to the negative n, we can basically push that number into the numerator with a positive power. So it's going to become a to the n power. So if an expression goes from the numerator to the denominator, it's going to change the sign of the exponent. That is what this means. Here is an example. If you have 5 to the negative 3, it can be rewritten as 1 over 5 to the third. Similarly, if you have 2 to the negative 1, it's the same as saying 1 over 2 to the positive 1. We usually don't write the power of its 1, but it is there. Okay. That one is not, it's not this one, it's that one. Okay. And to provide an example like this, sometimes we will end up with an expression that has, let's say, 1 over 3 to the negative 2. We can change that into a positive exponent because we don't know how to compute negative exponents yet. So we're going to push that up to the numerator to make it positive. It's going to become 3 to the second power, and we know what that is. That is basically number 9. If there is a number in the numerator, let's say there is a 2 here, then it is going to become, so it's going to become 2, that is the numerator, times the number I brought up, which is 3 to the second power with a positive exponent. So this is going to become 2 times 9, which is 18. So here is how you're going to use the negative exponent rule. It's extremely useful rule. The next rule is the power of a product. The power of a product. So if you have a product of expressions and you raise that into an exponent of n, then basically what you're going to do, you're going to distribute the power over the multiplication. This only works with multiplication and division. It doesn't work with addition or subtraction. Okay, so keep that in mind. It does not work with addition or subtraction. For example, a plus b raised to the n power is not a to the n plus b to the n. We call that the fool's dream. So remember, it is not applicable. Subtraction does not work either. So make sure you're only applying the power of a product rule and a quotient rule, so to multiplication and division only. You cannot apply that to subtraction or addition. So how do we go to explain that? So if you have a product of 2 expressions or numbers, then you raise that to a power of n, then that is the first expression raised to the power n times the second expression raised to the power n. For example, if you have 2x and you raise that to the fifth power, 2x is basically 2 times x. So you're going to distribute that over. So it's going to be 2 to the fifth power times x to the fifth power. If you have more than 2 expressions, let's say you have 2xyz raised to the third power, this is going to be 2 to the third times x to the third times y to the third times z to the third. I hope you get the idea. Okay? And now the final answer here is 2 to the fifth is a number. You can find it by multiplying 2 by itself 5 times. And then x to the fifth remains the same because x is a variable. So we just keep it x to the fifth. That means we have 5 x's multiplied with each other. Same idea applies for the power of quotient rule. So the power of quotient, if you have a quotient means division, 2 expressions divided by itself, and you raise that expression to an n power, any power. You're going to do the same exact thing we did before. You're going to distribute the n over the numerator and the denominator, which will give you a to the n divided by b to the n. Here is an example. If you have 4 divided by z to the 11th power and you raise everything to the second power, then you're going to distribute the power over the quotient, and you're going to say 4 to the second power and then divided by z to the 11th raised to the second power. Okay? Now, in the denominator, we're going to use the power rule. Okay? We're going to use the power rule in the denominator. Notice how there is a power and then there is another power raised to another power. We know that 4 to the second is 16. And then we're going to apply the power rule in the denominator, which means we're going to multiply 11 times 2. So we're going to get z raised to the 22 power. And we're going to keep that expression like that. There isn't anything that cancels out. So we're going to leave it like that. The last but not least is the rational exponent rule. If you have an expression raised to a rational exponent, rational means fraction, then we're going to write it as a radical. So the radical, the index of the radical is going to be the denominator of the fraction, and the numerator is going to be the power of the base. So here is an example. If you have a raised to the m over n, it's going to be the nth root of a to the m power. To apply that to our example here, if you have x to the 1/2, that is equal to the square root. We usually do not write the index of the radical. If it's a 2, that is the square root, the very common one. And then the radicand is x to the first power, which is also usually not written. So this is basically the square root of x. Here is another example. If you have x raised to the 5/3, this is the cube root of x to the 5th. Cube root of x to the 5th. So here, I didn't mean to do that. Here's the 3 goes into the index and the 5 goes into the power of the radicand. Here are some practice problems that we can do. Simplify each product. So we have a product here and we want to simplify the product. So as you can see, the first problem says c cubed times c to the 8th power. This is basically the product rule, the first rule. So we have the same base. That means we're going to keep the same base. And then the product rule says we add the exponents. So 3 plus 8. That is equal to c raised to the 11th power. And we leave it like that. B. B, notice how we do not have similar bases, which means there isn't anything that can be done here. We don't have the same bases. We do not have the same exponents. So we can basically leave it like that, okay? If I want to be a little bit fancy, I can rewrite this as a times a to the 5th times b to the 5th. And you see where I'm gonna go with this. I'm gonna use the power of a product rule backwards. I'm gonna use this one with that expression. So I can rewrite it as a times b, or ab to the 5th power, which looks a little bit nicer, but it doesn't actually give us any benefits mathematically. But sometimes you need to do these manipulations in mathematics in order to prove something or disprove something. Part C, we have 2x squared times 4x to the 3rd power. Again, I'm going to use the product rule in this case. We know 2 times 4 is 8, so no problem there. Times x to the 2nd times x to the 3rd. Now, this expression can be condensed using the product rule. So I'm going to do that. This is going to be 8 times x to the 2 plus 3 using the product rule, which will give me 8x to the 5th power. So that expression here turns into 8x to the 5th power. Part 2, simplify each expression. A. I have x to the 2nd raised to the 3rd. I know that the power of the power multiplies. That is the power rule. So that is what I'm going to do here. I will say, using the power rule, this is x to the 2 times 3, which will give me x to the 6th power. Now, many of you are going to confuse the power rule with the product rule. Notice the difference. Here I have 2 similar bases. They're multiplied together, similar bases with different exponents. Here I have one base raised to a power, and that expression is raised to another power. So here is a power of a power, or an exponent of an exponent. The third, part B. Part B says negative 3 h to the 9th raised to the 3rd power. Again, I'm going to use the power rule combined with the power of a product rule. So I'm going to use the power rule combined with the power of a product rule. Why is that? Because I have a product inside of the parentheses. So first, I'm going to use the product of a power of a product, because I have a product inside. So I will go with negative 3 to the 3rd times h to the 9th raised to the 3rd. That is the power of a product rule. Now I'm going to apply the power rule, because now I have one expression raised to a power. Then one expression with a power raised to another power. Negative 3 to the 3rd power is basically negative 3 times negative 3 times negative 3 times h to the 9th raised to the 3rd. Here's where the power rule is going to come handy. So this is going to be h to the 9th times 3. So negative 3 times negative 3 times negative 3 is negative 27. And then times h, 9 times 3 is 27. So here is the last answer and the final answer for this expression. Part C, I have x to the 5th raised to 1/5. So I'm going to use the power rule for that one because there is an expression raised to a power. So this is going to become x to the 5th times 1/5. Now, 5 times 1/5, when you multiply, when you're going to multiply fractions, remember that the numerator multiplies the numerator denominator with the denominator. The denominator of any integer is 1. So this is going to become x to the 5/5, which we can basically say 5/5 is 1. So it's going to be x to the 1 power, or basically just x. Okay.